Newton's first law, usually called the law of inertia, is a restatement of Galileo's idea that a force isn't needed to keep an object moving. In other words, things tend to keep on doing what they're already doing. Objects in a state of rest tend to stay at rest. Only a force will change that state. Now consider an object in motion. In the absence of forces, a moving object tends to move in a straight line indefinitely. Toss an object from a space station located in the vacuum of outer space, and the object will move forever due to inertia. Jets of air from tiny holes in the air hockey table provide a nearly frictionless surface on the air table. If you slide a puck along the surface of a city street, the puck comes to rest very quickly. If you slide it along an air hockey table where the friction is practically absent, it slides with no apparent loss in speed. The law of inertia provides a completely different way of viewing motion from the ancients. Objects continue to move by themselves. Forces are needed to overcome any friction that may be present and to get objects moving initially. Once the object is moving in a force-free environment, it'll move in a straight line indefinitely. The amount of inertia an object has depends on its mass, which is the amount of matter in the object. Mass is a measure of the inertia of an object. You can tell how much matter is in a can when you kick it. Kick an empty can and it moves. Kick a can filled with sand or rocks and it doesn't move as much. Don't confuse mass and volume. Volume is a measure of space, and it's measured in units such as cubic centimeters, cubic meters, and liters. Mass is measured in the fundamental unit of kilograms. Which has more mass, a feather pillow or a common car battery? It's pretty clear that the car battery is more difficult to set into motion. This is evidence of the battery's greater inertia and greater mass. The pillow has a larger volume, but a smaller mass than the battery. Mass is often confused with weight. We often determine the amount of matter in an object by measuring its gravitational attraction to the Earth. However, mass is more fundamental than weight. Mass is a measure of the amount of matter in an object. Weight, on the other hand, is a measure of the gravitational force acting on the object. The amount of material in a particular stone is the same whether the stone is located on Earth, on the Moon, or in outer space. The mass of the stone is the same in all these locations. The weight of the stone would be very different on Earth and on the Moon, and still different in outer space. The stone's inertia, or mass, is a property of the stone and not its location. The same force would be required to shake the stone with the same rhythm whether the stone was on Earth, on the Moon, or in a force-free region of outer space. We can define mass and weight as follows. Mass is the quantity of matter in an object. More specifically, mass is a measure of the inertia that an object exhibits in response to any effort made to start it, stop it, or otherwise change its state of motion. Weight is the force of gravity on an object. Mass and weight are proportional to each other in a given place. In the same location, twice the mass weighs twice as much. Mass and weight are proportional to each other, but they're not equal to each other. It's common to describe the amount of matter in an object by its gravitational pull to Earth, that is, by its weight. In the United States, the traditional unit of weight is the pound. In most parts of the world, the measure of matter is commonly expressed in units of mass, the kilogram. At Earth's surface, 1 kilogram has a weight of 2.2 pounds. The SI unit of force is the Newton. The SI symbol for the Newton is a capital N. 1 Newton is equal to slightly less than a quarter of a pound. If you know the mass of something in kilograms and you want its weight in newtons at the Earth's surface, multiply the number of kilograms by 9.8. 1 kilogram of nails weighs 9.8 newtons, which is equal to 2.2 pounds. Away from the Earth's surface where the force of gravity is less, the bag of nails weighs less.